Welcome to Module 10. Now, this is the number 9 practice exercise. So, this will be the 9th notebook that we have to go play with after the lesson's done. I'll play with it as I go through it, but I'll also, once I'm done, add in some stuff for you to go play with in here as well. And this should prep you for the fourth graded notebook. Now, in this module, what I'm going to deal with is modules, which different than when I say module relative to the course. We're talking about now programming modules. We're also, aside from modules, we're going to talk about, let's go open it up here. I'll show you what we're going to talk about. We're going to deal with modules. We're going to deal with packages. I'm going to talk about libraries, both the Python standard library as well as some other things that we could bring in as libraries. And then we're going to talk about some additional concepts that I'll hit on right now. So, in the last few modules, we dealt with object-oriented programming and different programming concepts that added more power to what we were doing. And over the different modules that we've gone through, there's a couple of phrases that I've used more than one time, or far more than one time. One thing I'll commonly say is I'm a programmer. I'm not lazy, I'm efficient. I don't want to have to go recreate something that's already been created and has been proven to work. That's not being lazy, that's being efficient and utilizing resources that already exist. And in programming, we outsource a lot of work to external entities that can perform the work for us. We don't have to do it. We already know somebody that can do it for us or some place to have it done. And the other has been along the lines of object-oriented programming. If somebody's created a template or a model of what something should look like, I don't need to create it from scratch. I can just make a copy of what somebody else has created. Now, this concept of using something that already exists or create something one time and use it multiple times, and I only have to write it once, and I can use it as many times as I want. Now, we've created loops in the past, and I can create a loop, I'll say a for loop, for in range 500, print hello. Now, what if I said for I in range 500, print I? It'll print numbers up to 500, but not including 500. So 0 on up to 499. Literally, that's 500 numbers, though, since we start counting at 0. Now, I can go through using a while loop, a for loop, and go through these repetitions, but I only needed to perform that task one time, and the loop structure took 500 tasks and broke it down into just 3 lines. So we're being really efficient there. Now, one of the things that I really haven't spoken about much is efficiency from a different perspective. I've been looking at it and talking about it from this viewpoint that we're being efficient with our time, being efficient and not having to write a lot of code. But we also need to be efficient when it comes to the processing power of the computer. And this is something that is generally not taught or not focused on until you get to a junior or senior level course in university or in college. But it's something that I want you to think about early on. That when we're talking about being efficient, it's not just about us, it's about everything impacted by our code, by our program. So we need to be efficient about memory. We need to be efficient about programming resources or processing resources. We need to be efficient when it comes to RAM and not tie up all the RAM and slow the program down. So there's a lot of things that we need to think about beyond just, well, I did it in 3 lines of code. Or I did it and all the code existed somewhere else and I didn't have to write much code at all. Now, when it comes to modular programming, Colab doesn't work well when it comes to modules. I love using Colab because 1, it's free. 2, it allows us to share a link and I can see what you're doing in real time. I can share my file out with you. You can make a copy of it. So it's, for the purposes of what we're doing, it works real well, but it's not 100%. So let's talk about what a module is and why we would want to use it. Now, in Python, runtime includes a mechanism for grouping code based on its functionality. Now, it's built into the language syntax itself, and it's referred to as modules. A module is a single Python file that's got code that we can use it over and over again. So when you think back to some things that we've done already, we've created functions, right? And we created functions. It's some block of code that performs a task. And I can use it as many times as I want or not at all. But it's sitting there for when I need it. And it's actually in my code. It's a block of code in my program, if you will. And here, let's while I'm talking about it, let's come down here, and I'm going to talk the very last module that I'm going to talk about, or the last video. What I'm going to cover in the last video is going to be this concept right here, using a main method and having this conditional statement here. I'm going to talk about that in the 4th video. Now, in the past, we created that object-oriented programming, and we were creating instances of some class that existed, and we can outsource work. We can create a copy of something somebody else has created, and in this code we see right here, we've declared or defined a function called guess. It receives 1 argument. It does some work. It's got a repetitious or a loop structure in here. And if somebody does something, we call this a sentinel. If this happens, boom, we will break. Or this is the else. Once we get through this, we break. So we'll go through until we're out. And this program here allows us to, let's run it. We tell it how many numbers we want. I'll go ahead, while it's running, it's actually running now. What we did was we imported a module that existed. It's built in. It's built into Python. Now, just because it's built in doesn't mean that it's there ready for me to use whenever I need it. Let's think of this along the lines of, yes, I own it, but it's not close by. It's out in the garage, or it's down in a storage unit, or it's in the trunk of the car. It's somewhere I can't get to it right now, so I need to go get it. And once I go get it, I can use it as many times as I want while my program's running. And this program's running. We see it spinning there. So enter the smallest number. So I want a number from 2 to 10. Give me a random number from 2 to 10. So it generated a random number from 2 to 10. Something that you'll deal with if you go on to a bachelor's program or a master's program. Something you'll deal with is algorithms relative to how to be efficient about guessing this number. Now, there's a best way to guess this number. And what we do is we call it a divide and conquer. And the way to guess this number with the least amount of guesses is to divide and conquer. So it's anywhere from 2 to 10. That's 8. So let's guess 6. That's halfway. We know that it's too high. So between 2 and 6, let's guess 4. Too large. I know what the number is now. It's either 2 or 3. So let's guess 3. Now I know the number's 2. So it wasn't that hard, and I figured that out in 4 tries. Now I could have said, you know what, I'm going to start at the bottom and work my way to the top, and eventually I'll get it. Oh, okay. Or I could start at the top and work my way to the bottom. Eventually I'll figure it out. But what if it's the last one? This divide and conquer logic helps us get through it really efficiently. Now, what we're going to do is we're going to come back and, like I said, we're going to talk about this concept of having a main method and having this little bit of line of code here to see if there is a main method, and if there is, go ahead and run it. And we've already done this concept before, where we define or we declare some function and we can pass it something, and it can potentially return us something or provide a service, whatever it may be. That's in our code. So if our code is running, it had to get through this, whether we used it or not. It had to get through this, and if this had variables in it, it had to go reserve memory for things. So this is taking up memory and slowing the system down, even if we don't use it. Now, what if, instead of doing this, we created a module that had this functionality in it? And I just say, you know what, import that module. Now, by saying import that module, it's, hey, get this so when I need it, we can use it. Now, it's not actually loaded up in the memory. I haven't done anything with it yet. But at some point, I can go run it. And it's not just maybe a single little block of code. It could be very comprehensive. But the thing about modules is everything in a module serves a single specific purpose. Now, a module is a single Python file. It's got a file extension of .py, and that code is reusable. Now, that code exists in that module, and it's accessible. You can get to it once you've imported it. We need to have it local. That's the problem we run into in Colab. So if I was running this, let's say I was running this in Anaconda or something on my local machine, maybe I was running Python on my local machine. As long as my module is in the same folder, and I can run as many modules as I want in here, import as many modules as I want. And this import statement, that's a linkage between my .py file and my program. So why would we use modules? Well, I don't want to tie up a bunch of my runtime when this thing's running. I don't want to tie up a bunch of what's going on with things that I really don't necessarily need right now. All right. So let's slide ahead a little bit, okay? And the way it all starts is we have to import the module. So there's some rules that we got to play by. One, it needs to be a .py if we're talking about a Python module. So it has a file name and then it's got the .py at the end. It needs to be local. And to be able to use it, we need to import it. Now, I showed you before, there was a quick little import statement, import random. Now, that's a module that exists, it's built in. And once we've pointed to it, all we have to do is utilize the functionality associated with it. So it's an import random, and well, what's that doing for me? What's random? Well, random is down here. Here's where it actually took place. We used that random module, and in it there's a rand int. It picks a random integer from smaller to larger. I got those two values from the user. And then it takes the result of that randomly generated value and it stores it in my number. And then we call that guess function and pass it that random number. And that's where we went through that back and forth to guess the number. So to be able to use it, we have to import it. And there's a few ways that we can go about importing things. I'll talk about them here in a second. But let's say I have this module. I create a Fibonacci numbers module. Now the way I wrote this, I can execute it and it doesn't come across as a module or class or anything like that. It's just, when we look at it, it's just two functions. Fib1 and Fib2. That's all it is, two functions. And the second one returns some value. Well, okay. So there's two functions in this module, and this module would have to have some name for me to invoke it or call it. Now, the code here, I didn't put it in a code block because if somebody turned around, let's say I shared this with you, and you click runtime and run all, this is going to throw an error, and it gets too ugly and too confusing. So I just put the block of code in here so we can see it and walk through it. So we import Fibo, F-I-B-O. Now the name of the file was fibo.py. That's what I named it. fibo.py. .py is the file extension. I don't need to be that explicit. I'll just call it by name. Import fibo. Python goes and looks to see what's out there named fibo. It finds it. It creates that linkage. And then once I've got that connection, I can refer to anything in it. So I say Fibo, that's that module, .fib, ooh, that's that first function that's in there. So I invoke that one function and I pass it a value. And what does it do? It prints something out. The other returns some value. Now when we look at it, we did 1 to 1,000, we did the other to 100, had one printed out and had the other return the value. And it returned the value as a list of numbers. If we want to find out what the name of Fibo is, Fibo. Now, that sounds kind of funny, doesn't it? I'll talk about it more in a second. Now, we can get specific and take whatever a function does and store it in some value. We can do that. We can invoke the function without being explicit. Once I've imported it, I can implicitly point to fib if there is no other fib. I prefer to be explicit so there is no confusion, because you may, and I've had it happen to me more than once, you may import multiple modules or libraries that have methods or functions with the same name. And if you don't point to what it is that you're talking about explicitly, you may end up with something far different than what you think you're getting. Now that leads us to the concept of aliases. And let's come down and look at things here. Now, this is coming from the book. From random, let's import choice. And what that essentially means is randomly pick one. Okay? Randomly pick one. So it's going to randomly, the random module that exists, we're going to import choice. Choice is something that's very specific, and let's go get this choice function or choice method, and we're going to pass it this places list. Now, since I dumped it into a class, I need to be a little more explicit or it's not going to know what I'm talking about. And I went and did it that way. And if we do this, say I run it, executes the code, imports choice from random, and then we go run it, and it arbitrarily just picks one of these places to go for dinner. Now, that's doing it as a class. I don't want to necessarily do these things as a class, create an object, because that ties up a lot of resources that I really may not want to use or get in the way of things, if you will. So remember I said, let's go about things a little bit different. Let's be explicit about things. And I like to give these things an alias. Something that short, to the point, and I know what it is based on at a glance what I'm talking about. And it's an alias for the module that we've imported. So let's say I import a module named fast. Now I've commented this out because I don't have a module named fast that's local. So I've commented this out so it doesn't throw an error. So if these comments weren't here, import fast as F. So essentially what that's saying is import fast and everything that's in it, and moving forward we're going to call it F. F.pick is place. Well, F is just an alias or a nickname for fast. Fast has a method named pick. So everything that we did up here, if I did it in a module, this is how we would reach out to it using an alias. Okay. So I could essentially go run this, and if it was local, it would work, and we'd be all good. So that F is the alias for the module. And by putting it there, I could have multiple modules that use a function named pick. I know which one is getting invoked. That's essentially all that means. All right. We're not tied down to just importing the entire module. I can be focused and say, you know what? I don't want to go get everything. I only need one little resource in that module. So let's just get pick from there. From fast, import pick. I didn't import everything. I only went and got that method. I could run it and boom, it would work for me. Right? I can go create that method as an alias. So this went through and said, well, let's go get pick. This says from fast import pick as who cares. So I didn't get the module and give it a nickname. I got that method or that function and gave it a nickname to something that I may be more familiar with or more comfortable with. I call it whatever I want. And that's what that alias aspect is. Okay? So that's what we're dealing with when we're dealing with modules. Right? Being able to take these functions that we've created and you know what? I'm going to push them out to external files. And then instead of having lines and lines and lines and lines of code in my program, I can have a real short program that points to all these external modules. Okay? And there's rationale behind why we do that. Right? And you know, it all has to do with being efficient. It really does. Now, we'll call these modules, they're like scripts, to where I've got this little .py script and I can run it, use it, do whatever I need to. All right, so you may hear the word script or module. They're about the same thing. They're files that have code in them to perform a common task. Everything in that program or in that .py file is geared towards a common single task, one single purpose. Okay? Now, I'm going to go ahead and end this video. We'll come back with the next one, and we're going on to packages.